morning, everyone. Welcome to DevOps Days Birmingham 2023. My name is Jim Barton, and we are going to talk about Istio Ambient Mesh in a workshop format. So if you are an engineer and you're inclined to follow along with us, I encourage you to get your laptop out, and we will have an exercise for you to go through here in just a moment. Like I said, my name is Jim Barton. I am a field engineer here in North America with Solo. I've been doing enterprise computing for so long that I lost my hair in the process. There you go. Appreciate that. And I'd love to connect with you on socials if you're so inclined. Like I said, today is an interactive workshop, so I want to go ahead because it does take a couple of minutes to spin things up here. So before I talk through just a couple of context setting slides, I want to invite you to get your laptop out and connect with academy.solo.io. If you don't have an internet connection yet, the access point is DevOps, and the password, is it okay if I say this on the recording? The password is DevOps Days, no caps or spaces or anything. So that will get you on the network. And then if you go to academy.solo.io, you can scroll down to here, and you'll see should be the first course listed here is called Get Started with Istio Ambient Mesh. If you click through that, you will see something. Your display will look slightly different than mine. You'll see there are a couple of preliminary exercises here before the hands-on lab. We're primarily going to be focused on the hands-on lab today. Unfortunately, what you have to do, you cannot go directly to the hands-on lab. You have to click through the introduction first, and then just go click on the next button there, and that will take you to a demo. Don't worry about that. You're actually going to be building this on your own. And anyway, then once you have viewed those two, you click the next button once again, and that's going to take you to the hands-on lab exercise like this. And if you hit the, I believe there'll be a launch button. There was a launch button there. Here we go. Okay, see that green launch button there? Go ahead and hit that, and that's going to start provisioning your environment for you for the workshop exercise. So we'll let that be spinning up in the background while I am doing some intro material here. Okay. So let's go ahead and I'm going to start the track on my side. That'll take just a couple of minutes. So here we go. So and if you're so inclined, if you enjoy this stuff so much, at the end we'll have a certification exam that you can take either here or later today when you get home, or tomorrow, and that will allow you to earn this fundamentals of Istio Ambient Mesh badge that you can proudly display on your LinkedIn profile if you're so inclined. So we invite you to do that. That's also on that Solo Academy interface that you hopefully have been introduced to now. Okay. Just a quick show of hands here. How many of you have deployed Istio in production? Okay, no, sort of. Okay, how many of you are using Istio in say a dev environment? Okay, all right, got a few hands there. What about other service mesh technologies? Linkerd, Kuma, other options that are out there? No, so it's an all Istio room. All right, that's good. No tomatoes will be thrown my way. Excellent. How many of you can spell Istio? Okay, all right, that was just a check to see who's awake. All right, very good. All right, so let's talk just a little bit about some history here, which I think is really interesting because Istio fits very well into what's happening in the cloud-native computing space in general right now. So Istio's actually been around since 2017 at this point, and really came out of the proliferation of moving from kind of monoliths to microservices, right? So in the olden days, we had, we could make assumptions that we had a small number of monolithic applications, relatively speaking, that we needed to manage. And then as we started moving more toward microservice deployments, what happened? The number of actual deployments exploded. We started getting involved in interesting container orchestration environments like Kubernetes, and there was a lot more complexity to be managed there. We needed to know how to be able to connect to and discover services that may be more ephemeral, that are more ephemeral than they were in the past, right? There's not just a small set of static blocks that are sitting there, right? Static service blocks that are sitting there. Now we have potential, whole fleets of microservices, and some of them are spinning up, and some of them are going down, and some of them there may be bad network connections that need to be navigated. And so just being able to connect these complex interconnecting networks is a challenge, right? And to be able to secure that, to ensure that the connections within all of those applications are secure, and to be able to bring traffic selectively in from the outside world and expose just the service interfaces that we want to that outside world, right? That becomes a challenge. And then, oh my, we have to debug this stuff now, right? We have to be able to observe what's happening inside our application networks, and that can be quite a challenge, right? We, rather than having a handful of connections, now we have a large number of connections, and what if a network connection goes down? What if a service instance goes down? I need to be able to see that, observe it, and understand in more detail what I can do to fix that. And so Istio comes out of that frame of reference. And so as a service mesh platform, it's all about connecting, securing, and observing networks of applications. One of the key technologies it uses to do that is something called Envoy proxy, right? So if I show of hands on who knows what Envoy proxy is, okay, most everyone. So basically the idea with Envoy proxy is it's a foundational technology within Istio that allows us to proxy connections between services, right? So I have service A that needs to talk to service B. Basically, I can put an Envoy proxy, or in the case of classic Istio, a couple of Envoy proxies in that request path, and that gives me the opportunity to apply policies at that point. It gives me the opportunity to observe what's happening on those connections between those services, to be able to secure the connectivity between those services, and to do all of that without requiring changes to the underlying application code, right? If we were trying to solve these kinds of problems 10 years ago, each individual application team is going to be going out, and they're going to be, finding, SSL libraries and maybe libraries to manage connectivity and apply certain kinds of policies and that sort of thing. And we don't want that burden on our application teams. We want to be able to offload that and to let the infrastructure handle that on our behalf through a set of policy-based declarations, right? And so Istio, Envoy, and then in the interim, since then, there's actually been a ton of experience that's been gained with Istio. It really has taken off, especially as Kubernetes adoption has moved from what I would consider day one sorts of concerns to day two sorts of concerns. So now we're concerned about things like resilience and multiple clusters, and basically scaling up some of the complexity that's associated with cloud-native services. And so Istio has quite a large following now. By most accounts, it is the industry's leading service mesh at this point. It's also been donated to the CNCF as of actually about a year ago now. And so as a result of all of this experience, we have a number of leaders in the community, most notably Google and Solo, have figured, we've learned some things, and we know that that there are some ways that we can improve the architecture of the architecture of Istio, and that's where the ambient mesh came from. Just an interesting little origin story there. Basically what happened is Google and Solo were working in parallel on very, very similar sorts of architectural changes, kind of figured that out that we were working on the same things, joined forces, and then contributed that to the community as a single sort of unified offering. So Ambient Mesh comes on the heels of a lot of experience with Istio production deployments, and we'll talk a little bit about why, and then give you some experience actually using it here. Okay, so Ambient Mesh is an open source contribution to the Istio project. And it defines at a technical level, the significant thing that happens here is that Ambient Mesh defines a sidecar-less data plane. Why is that significant? Well, if you look at the traditional data path of an Istio request, you see something like the diagram on your left there. So each of the light blue boxes represents a service. Each one of those services has injected into its container an Envoy proxy that basically proxies all traffic in and out of that service. And so you typically have these two fairly expensive layer 7 HTTP traversals that happen on each, but both going into and out of services as they're communicating with one another. And so at a technical level, what's happening with Ambient Mesh is basically replacing that requirement for having kind of layer 7 proxies attached to each service, and replacing that with the architecture that you see on the right, where with each node, there is a layer 4 proxy, which is much lighter weight, much smaller, that's actually shared across the services within that particular node. And then optionally, if you are applying layer 7 policies, then you may have an additional layer 7 policy, a layer 7 Envoy proxy in the path of the request. So this turns out to be much lighter weight, much more performant. And I think perhaps the most significant thing that this does is it really simplifies operations at scale. Let me give you an example of why. Let's say there is a CVE that affects Envoy at layer 7, right? So if you look at the history of Envoy CVEs, most of them are at layer 7 because that's where most of the complexity is. So you have a security issue. At layer 7 of Envoy proxy. So therefore, you need to refresh your entire application network. Now, let's say you have thousands of services in that application network, and each one of those thousands of services has an Envoy sidecar attached to it with Istio. So what has to happen then? That rollout process becomes a pretty heavyweight operational burden, right? Even if you have it automated, it's still a lengthy process to get that number of systems refreshed and restarted, and new versions of Envoy proxy injected, and so forth. And so these are the kinds of day 2 operational concerns that Ambient Mesh really addresses in spades, because it allows us now to have a single shared layer 4 proxy on a per node basis rather than a per container service basis. So it's much lighter weight, it's much easier to operate. There are also some important cost benefits as well, because you don't have to provision as much computing resource to support just the operation of the Istio network, and yet it still supports the same expressiveness in terms of policies that you can apply inside the network, and we'll actually be doing that in our example today. Okay, that's enough about slides. Hopefully at this point you have all been able to spin up an environment, and you've been able to launch that. You're perhaps looking at a screen that looks something like this. If you are, hit the start button there, and that's going to take us into instruct. So what we're going to do here over the next 45 minutes here is we're going to deploy an environment and then set up ambient mesh, and we're going to apply some policies. And if we have some time at the end, we also have a little bonus exercise where we'll show you how to interoperate between kind of classic Istio, sidecar injected Istio, and ambient, which is sidecar-less, and how you can connect the two. But before that, let's just go through some basic installation here. If you haven't used Instruct before, what you'll notice here in each of these command blocks that you're going to be using, over on the right side, there's a little icon here. You click on that, right? It turns green. That puts it in your copy buffer. Then you can paste it into the terminal here on the left. And so we can walk through these scenarios with very little risk of messing up the configuration, which is good. Can everyone see? Everyone who's looking at my screen, can you see? Maybe make it a little bigger. Okay, how's that? All right, let's try that. Okay, so the first thing we're going to do, and this takes just a couple of minutes to spin up as well. We're going to establish a kind cluster here, and it's a kind cluster that has 4 nodes in it. So we're trying to give you something that as much as we can in this sort of a workshop environment, simulates a decently real-world scenario. So we're going to let the kind cluster spin up here. So we'll have our own everyone will have your own individual kube cluster. It's a 4-node cluster. One of them is going to be dedicated to being control plane. The other 3 are going to be workload nodes within our cluster. And so let's let that spin for a bit, and we'll run a check script when that's over just to make sure everything is okay. Then to give you a preview of the rest of this exercise, we're going to deploy Istio, and we're going to deploy one of the newer release, or actually the newest release of Istio that's still in beta at this point. And the reason we're going to use that one, so we have had ambient in experimental branches of, say, the current release 1.17 of Istio, but in the branch that's under that's under development, 1.18, Istio is actually part of the main branch, right? And so it's something that is, with the release of 1.18 coming up shortly, it's going to be a fully supported feature of Istio, and we think that's a really important milestone that we want to highlight by using the 1.18 version. So we're going to install the 1.18 version of Istio. We're going to do that using the ambient profile. And so that ambient profile is going to install, obviously, the core aspects of Istio. So the Istio-D control plane will be there. We'll have an ingress gateway that's going to be installed that we'll use to manage traffic coming from the outside. We're going to install a CNI that's going to be responsible for managing the traffic redirection, because now, right, we're changing the architecture of our data path. We're no longer injecting a sidecar with each individual workload. We're going to have a per node layer 4 proxy on each machine. And so we're going to have this CNI component that's going to make sure that the traffic redirection between the workloads and the proxies is all established properly. And so we're going to set that up. We're going to set up something called the Z tunnel. The Z tunnel stands for Zero Trust Tunnel. That's actually the layer 4 component that is installed on a per node basis. And so those represent the elements of Istio that we're going to be establishing with the ambient profile. So it looks like our kind clusters have spun up at this point. So let's go ahead. I'm going to run this check script here, which should return pretty quickly. Yep, everything looks good there. And so now I'm going to go ahead and download the 1.18 Istio version. All right, that usually goes pretty quickly. And then we're going to install Istio using the ambient profile. Istio, of course, has a number of profiles that you can use, everything from like basic sort of demoware up to more full production profiles. In this case, we're going to select a profile that specifically has just the key elements that are needed to show ambient mesh. So that's going to take just a few minutes to install those components. And just to give you a preview of what's actually going to be there once it's installed, these are the pods that are going to be running for us here in this display. So you can see, remember, this is a 4-node cluster, and so we have a CNI component that's deployed on each one of those nodes. We also have the Z tunnel, which is the layer 4 proxy that proxies the traffic that's installed on each one of those nodes. In addition, we have the Istio D control plane, which is responsible for programming these proxies based on the policies that we're going to specify. And then we also have an Istio Ingress gateway that's going to apply policies at the edge of our application network to allow traffic in and establish the behavior that we want to get to. Okay, so it looks like Istio is installed with the ambient profile, and so that's all good. So let's take a look and just make sure everything is up and running like we expect. Yep. So those are the nodes we expect. You can see they're all in a running status, so that's good stuff. And we're going to do one more installation task here, and then we'll be done with kind of Kube and Istio installation. We want to install the new gateway API CRDs that come with Istio. The reason we need that is because we're going to use that when we get to layer 7 proxies, or basically providing policies to support layer 7 specific operations, like particular kinds of HTTP ops and headers and so forth. We're going to need this. We're going to need this gateway CRD installed. So we're going to go ahead and install that now. That usually goes pretty quickly, and then we're going to turn our attention to the actual application services. Everyone with me? Everyone who wants to, who's following along, good so far? All right, thumbs up. Great, thank you. All right, so now let's turn our attention to the workloads, the services, quote unquote. I use that term loosely, that we're going to be using to sort of illustrate what we're doing here with ambient mesh. And so what we're going to do, we're going to create something that basically simulates a flow in an e-commerce app. So we have 3 services here. We have a web API service, we have a recommendation service, and we have a purchase history service. So imagine, right, you're at the end of, you just purchased something from, from Amazon. Someone's going to hit the web API service, and they're going to say, okay, let's make some more recommendations to this user based on what they've just purchased. And so it's going to look at what you've purchased now. It's going to look at it's going to call a recommendation engine. The recommendation engine in turn is going to look at your purchase history and see if it can infer some magic there that will cause you to buy something else. So that's the basic flow we're going to be simulating. We're going to install these three services into our environment. So we're going to have a call chain that looks something like that. We have a client app, which is either going to come from outside the environment or potentially from this sleep app in the environment. It's going to call web API, which leads to a chain of recommendation and purchase history. Now, you may think, wow, Solo went to a lot of work here to put all of that together, those applications together. Don't worry, we really did not. So what we're doing is we're using something called the fake service, which you can see right here. The fake service is very simple. It just gives you a way to sort of simulate call chains in a distributed environment. So basically, when you configure the fake service, you basically give it's like, hey, echo this string out, and you can potentially set up other calls for it to make so you can establish a realistic looking call chain. And so what we're going to get is we're going to get back a series of status messages that indicate, okay, here's the web API called recommendation, which is called purchase history, and we're going to get a display of all 3 of those. So we're just going to be deploying this fake service here. All right. Now, so let's go ahead and do that. There's nothing special about these deployments here. There's nothing Istio specific. We're simply going to create a namespace, and we're going to deploy these fake services, okay? And let's just make sure those are all installed properly. That all looks good. You can see here the pods, right? We've got the 2 client pods we're going to use, sleep and not sleep. Basically, sleep is in the mesh, not sleep is not. And we're going to set up these 3 workloads: purchase history, recommendation, and web API. So that all looks good. So just to show you, let's just do a basic test, right? We've applied no policies. We haven't introduced these, or we haven't applied these services into the mesh yet. So if we go to our sleep pod and we hit this interface, it should all work just fine, right? Just standard kube stuff here, right? So you can see initially we hit web API. Web API makes a call to a different upstream, the recommendation upstream, and recommendation then in turn calls version 1 of the purchase history service. We'll come back and switch versions later on in this exercise. So, all right, so everything is working there. That all looks good. We have our workload services out there, and we can hit them from inside the cluster. Now what we want to do is we want to publish this service to outside the cluster. So we're going to do that using the Istio Ingress Gateway, just again standard Istio techniques here. And just to show you very quickly, there's nothing special that's going on here. All we're doing is we're establishing a gateway component. Right, that gateway component is simply going to look for traffic coming into this istioexplain.io host, and it's going to be listening on port 80, and it's going to use the Istio Ingress gateway. Then we'll also establish a virtual service. The virtual service, again, is very simple. We're not doing anything fancy here. We're simply saying, okay, for traffic that's targeted at this host, we're going to select this gateway, and then we're going to redirect all of that traffic to this web API service that we just established a couple of minutes ago. Okay, so let's go ahead and we will apply that. Expose the web API service here. All right, so that's all good. And now we want to, let's go ahead and get the gateway IP address into an environment variable here. And then let's try this out. So let's hit istioexplain.io, which should take us to the web API service. So basically we're coming in now from the outside, right? We're coming in from the outside to our cluster, and indeed our gateway is exposing this endpoint just as we expect it to. All right, so this is all just base, obviously, configuration and setup stuff. Now we're actually going to start to get into the guts of what Istio Ambient Mesh does. Okay, so thumbs up, everyone good for this point? Who's following along? All right, very good, thank you. So go ahead, hit this check button. That's going to do a basic smoke test to see are things in the state they're supposed to be. If everything checks out, which hopefully it does, you'll get the green bar, and we'll go to the second session, and I'm going to get a drink of water. All right, very good. So what we're going to do in this second exercise, we're going to add some services to Ambient Mesh. We are going to look at we're going to start with just kind of the baseline layer 4 capabilities. We're going to do some layer 4 observability and also some layer 4 authorization policies in this exercise. So what we've seen in our experience with Istio adoption at Solo is there's a lot of things you can do with Istio, right? So where we see a lot of people coming to us initially is with compliance requirements. So let's say you're a large financial institution or perhaps some kind of government agency, and you have a compliance requirement. All of the all of the traffic within my service mesh has to be encrypted, right? We can no longer assume that perimeter security is adequate, right, to secure our systems anymore. I know I've been involved in situations where, bad guys get in, and if you don't have your internal services secured in some fashion, you can be in big trouble. And so a lot of people come to us with those requirements, and so really all they care about in terms of initial adoption of Istio is they care about the layer 4 stuff. They care about being able to, let's say, secure the traffic, their inter-mesh traffic using MTLS, right? So all of the connections, all the traffic is encrypted, and you can prevent things like man-in-the-middle attacks and so forth. So that's a very common use case, and people don't always want, organizations don't always want the layer 7 capabilities straight out of the box. And so one of the things that Ambient allows you to do that's very nice is you can incrementally adopt Istio in that fashion. So if all you care about are the security aspects, you can adopt that with just this kind of simpler architecture where you only have these per node layer 4 Z tunnels deployed on each node, and you don't have to have any layer 7 proxying happening within the mesh at all. And so that can be an important benefit for a lot of customers who want to adopt this in a more incremental fashion. All right, so the way that we're going to add these services to Ambient is very simple. We're simply going to label the namespace using this label right here, Istio data plane mode equal Ambient. And once we do that, well, let's not do that. Let's do this. And once we do that, what's going to happen is for this namespace, which includes all of these, the web API recommendation and so forth services that we installed, it's basically going to activate this CNI node that's on each layer, which is going to manage the redirection of traffic through this zero trust tunnel that lives on each node. Okay, so in fact we can confirm that if we take a look at the logs for this CNI node. You can see Ambient is kicking in right here. It's adding pods to the IP set. It's basically redirecting traffic. You see where it's adding a route here to get from one service to the next. And so it's basically it's enforcing the redirection of traffic to and from the services through their local layer 4 Z tunnel. Okay. And so you can see that, you can get a glimpse of that from the logs there. Okay, so now once these services have been added into the Ambient mesh, in fact, another thing that's interesting here, so note that we've now activated Ambient mesh within this namespace, but if you take a look at the pods that are here, right, okay, let's pay particular attention to this test namespace here. You can see all of these pods. These are all listed as one of one, right? What would happen in a typical Istio environment when you activate Istio is you're going to see there's going to be an Envoy container an Envoy container that's injected into this pod, and so there are going to be two of two ready components here. One is the actual application workload. Another is its resident proxy. And so in this case, we're not seeing that because we're simply routing traffic through this Z tunnel component that you can see are deployed here on a per node basis. Okay? So, yeah, sure, question? Do you have to have a particular CNI to work with Ambient mesh is the question. So you're thinking about like Kube CNI, like Cilium or Calico or something like that. No, it'll actually work with you can use standard out of the box, or if you want to use Cilium or Calico or something else, that's fine as well. This is simply, this CNI component is strictly focused on managing the Istio direction or redirection of traffic. Yeah, that's a great question. Thank you. All right. So we have added services to our ambient mesh by labeling the namespace. We've confirmed that that is working. Okay, and so what's going to happen now? If you take a look at the data path, it's actually going to look something like this. So here's the node boundary right here, and so we have a client that has a Z-tunnel on its local node. Let's say it wants to make a call to Web API. What's going to happen is that traffic, there's not going to be a direct connection here, right? The traffic's going to go through this Z-tunnel. It's going to go through this Z-tunnel connection here, and then it's going to be directed to the appropriate service on each one of on this node. Okay, and all of that is controlled by the Istio control plane. So you still program the control plane using policies, using Kubernetes custom resources, just as you did before, only now it's going to be programming the Z-tunnel components instead of the injected Envoy proxies. Okay. So that's what we're going to be seeing here that's going to happen. So let's generate some traffic, and then we can take a look at this. We'll take a look at some of the metrics that we're going to get first, and then we'll establish some policies to actually control the traffic flow. So let's go ahead and from our kind of sleep client, we're going to make 100 calls off to Web API. You can see those all returned successfully there, and then we want to confirm, hey, are the Z-tunnels really mediating this traffic as we expect them to? And so if we take a look at the Z-tunnel logs, you can in fact see that here. If you trace through, you can see there are the access logs for the Z-tunnel are showing you both the inbound and outbound traffic from the Z-tunnel to the various application components that we're connecting here to. So the Z-tunnel is active. It is mediating the traffic, and we can take a look at some of the metrics that are generated here. So if we hit the metrics endpoint that's actually published from Istio, you can see that we're capturing. This is showing a particular metric, TCP sent bytes total, and you can see for each one of these connections, you can see it's reporting basically the number of bytes that are going into and out of each one of these components. So we still get detailed metrics based on what each one of these services is doing, and that's a good thing. Now, this next section gets into a really interesting part here, and that is that is specifying the policies at layer 4 with just this Z-tunnel established. So again, this is standard Istio policy here. And all we're doing is we're going to start with best security practice. We're going to deny everything, right? We're going to deny everything, and then we're going to use a least privilege access sort of strategy to build up just the connections that we want to allow within our mesh, right? And of course, we're doing all this in a policy-based fashion, right? We're not doing anything to the source applications. In fact, there's not even Envoy proxy attached to the source service components at this point. We're doing all of this via the per node Z-tunnels at this point. So first, we're going to establish an Istio policy that just, nothing gets through. And so we'll establish that, and then if we try to make the same call that we did before, what you're going to see now is it's going to be rejected at layer 4, right? Upstream connect error. We can't get to it anymore, and that's what we're after. So now let's think about what we want to do in order to establish just the paths that we want to allow through this service. So to do that, we're going to establish a series of authorization policies that are going to basically activate just the paths that we want to allow from between the actors where we want to allow them. All right. So first, we're going to attach something to Web API, we're going to allow traffic there, and the rule that we're going to specify is we want to allow traffic to Web API from two sources. One of them is from this sleep pod that we have deployed in the mesh, and then also from the Istio ingress gateway, which is, of course, how we get traffic in from the outside of the cluster into our mesh. So that's one of the policies we're going to establish. We're going to allow two paths from two different identities to come into Web API. But then for the other services, we're going to lock down those connections more tightly. You know, let's say for the recommendation engine, right, the only place we want to allow traffic to come into that is from this Web API service. And so you can see that rule specified right here, where we're only going to, for the Web API, we're only going to allow traffic, I'm sorry, I said that backwards. For the recommendation service, we're only going to allow traffic coming in from the Web API. So, you know, no one's going to be able to just randomly come in and invoke that service. Similarly, for purchase history, it's a similar story. We're only going to allow access to purchase history from the recommendation service. So we basically have locked down just the paths that we want to allow to be activated here. So let's go up here and we will apply those authorization policies. Okay. And now, let's test that out. So if we try to access Web API from this is from the outside world, so this is traffic that's coming through the ingress gateway. That's fine, right? We specifically authorize that, and that whole request chain has been activated. So that's all good, just like we expect. But if we come in from some other place, so this not sleep pod, which we have not authorized, then, you know, what do you see there? You're going to get the same sort of layer 4 connection error that we got before, because we're explicitly denying that. And so it's a much easier, much lighter weight way to activate these sorts of policies in your service network. All right, I need to move along pretty quickly here. So, assuming everyone is following along that wants to follow along, question?
So you're setting the unauthorized
That is a fantastic question. It's not something we're going to cover here. So the question, to repeat for the camera, is, so we're setting inbound policies here. Is there a way to set outbound policies as well? Yeah, absolutely. You can control both network ingress as well as network egress using Istio, establishing destination rules and external services. Basically, you can the preferred best practice from a security standpoint is lock Istio down so that you cannot make external service calls unless it's specifically authorized. So especially if you're responding to, you know, about a little over a year ago, we had the Log4Shell exploit, where the whole exploit was based on a service sort of, you know, unexpectedly making a call to some external service that would then serialize Java objects in and do malicious things, right? If you're using something like Istio with a security policy that disallows all external calls that haven't been specifically authorized, you can shut that sort of exploit down very easily. All right, yeah, great question. Thank you. All right, so at this point, we're at the end of the second exercise. So I'm going to go ahead and hit the check button here. Hopefully you can do that as well. We'll do a little smoke test. Everything looks good. And so that gave us an introduction to kind of layer 4 policies with Ambient Mesh, as well as some layer 4 observability. You can see we were able to do that without injecting sidecars into each one of our application services. We simply established a per node proxy in the infrastructure, which is, of course, much easier to upgrade, much lower cost to operate, that sort of thing. Okay, now let's talk about, we're going to shift our focus now, excuse me. We're going to shift our focus now from layer 4 policies and observability up to layer 7. So let's say, like many of us do, we want to apply things based on HTTP elements of our request. Like, let's say we want to allow a particular type of operation, a get versus a post, or perhaps we want to activate things based on a particular HTTP header, maybe activate a path, that sort of thing. So we're going to talk about how to do that. In an ambient mesh context, again, it is much lighter weight than sort of the classic Istio model. So we'll talk about authorization policies, we'll talk about observability, and then we'll show you a couple of examples. We'll show you a fault injection policy that operates at layer 7 and also a traffic shifting policy where we're basically upgrading a service from version 1 to version 2. All right? So that's what we're going to do in this exercise. We are going to be moving pretty quickly here. So let's start this up, and we will begin with layer 7 authorization policies, right? So sometimes you need more than layer 4, right? You need layer 7, as we were just talking about. And so our data path is going to look somewhat different in this case. So let's say, as our first example is going to show, let's say we want to allow GET requests between a particular client and a particular service, but we don't want to allow other kinds of HTTP requests, no posts, no deletes, that sort of thing. And so what's going to happen, so before, when we were just operating at layer 4, you'll recall that we had our services connecting to a Z tunnel, the Z tunnel talking to another Z tunnel on another node, and then connecting to the target service. Now, because we're adding layer 7 into the mix, we're going to add a new element to the data path. So in addition to the Z tunnels, which still managing traffic encryption and that sort of thing, we're also going to add something called the waypoint proxy. The waypoint proxy, because we are operating at layer 7, it is a full up layer 7 Envoy proxy that also the same Istio control plane knows how to program. Okay, so still lighter weight than the typical classic Istio path where you have 2 layer 7 proxies, one attached to both the target and the source and destination services. But it does add an additional component to the data path here. All right, so let's show how that works here. So the first thing we're going to do to establish that, so waypoint proxies are not deployed by default. So the first thing we're going to do is we're going to deploy a waypoint proxy that corresponds to this web API service, right? So waypoint proxies typically operate on a per service or per service account, per identity basis. And so we're going to establish a waypoint proxy that's devoted to managing traffic for this web API service. All right, so let's go ahead and we will deploy that out there. That's going to spin up that waypoint proxy, and it looks like that has rolled out. So let's actually confirm that. We'll take a look at what's active in this namespace, and you can see here is a waypoint for the web API identity. All right, so that's all good. And now we're going to establish our layer 7 authorization policies. Okay, so specifically what we want to do here is we want to allow coming into coming into web API. If this happens to you, it's okay. I activated the browser there by accident. We should still be good here. All right, we've applied that policy. Let's make sure the pods are there. Okay, everything looks good. So anyway, now we're going to apply this policy that allows only GET operations. All right, so we're operating HTTP layer 7, only GET operations into the web API service. Anything else, a post, a delete, a put, is going to fail. So that's not what I wanted to do there. There we go. Okay, so our policy is activated, and now to test this out, let's do the same thing that we have done before, where we're going to issue a GET to this endpoint. All right, that works just fine, but now if we try to do something different, like let's say a delete, you can see that on the command line there, the delete operation, right? that is going to fail. And because this is operating at layer 7, right, you get back a nice HTTP 403 forbidden code here as well, just like you would expect. And of course, we're still all doing this. We have not modified the underlying applications, and we've not had to establish layer 7 proxies at both ends of the connection. We simply have a single one in the middle that is serving that particular service identity. All right, let's talk a bit about observability. So, if we hit the Prometheus endpoint, right, you can see here we're getting back. We're specifically looking at the Istio request total. So this is coming from the waypoint proxy, and you can see if you dig down in here, you can see, all right, there's our response code 403. So we've had 2 of these that have failed, right? We've had one that has succeeded with a 200 code, and you can also see what interconnections they're addressing there. So, yeah, question.
Policies you have to define how to reply to
That's actually the default. The default behavior is 403. I believe you can customize that, but yeah, in this case, we just accepted the default. Yeah, good question. All right, so this is so that's all working. So we're doing some basic authorization. We're doing some basic observability. Now let's look at some specific, because with layer 7 now this opens up a whole new set of policies that we can apply here, right? And so for example, things like fault injection policies that you can specify with Istio, we can now apply that in the context of the ambient mesh deployment, right? So there's nothing different about the policy itself, but the way it's applied is different with ambient. So what we're going to do here is we are going to inject a 5-second delay into our requests here, right? So this might be useful for you. You're trying to test resilience of your services. And for some reason, or perhaps in this case, for some reason, we don't like the user Amy, so we're only going to inject this 5-second delay into requests that have the header with the value Amy in it. I don't know why we don't like her, but we don't apparently. And so let's go ahead and we will apply that policy. And so if we then make an invocation, right, just like before, with notice the header for user Amy there, what you're going to see is 1, 2, 3, 4, 5, roughly. I counted a little fast. So the call still works, but there was a 5-second delay there. If we switch to some other user, let's say Jim is our preferred user here, right? You could see, right, that went through immediately without any delay. So again, you can deploy those kinds of policies very easily with ambient mesh. Traffic shifting, right? We're going to introduce a new version of a service. We're going to have a version 2 of the service. We want to be able to do a traffic split across those versions. And so let's go ahead and we will put version 2 of our, this is the purchase history service out there. We need to establish, because we're going to be applying layer 7 policies to purchase history, we need to establish a waypoint that's going to manage those layer 7 proxies for purchase history, and then we're going to do a specific authorization policy here for layer 7, for purchase history at layer 7, where we're going to identify who's allowed to call it. So in this case, just the recommendation engine. And we're going to, here's the key part here, we're going to split the traffic across these two. So 90% is going to go to version 1, 10% is going to go to version 2. Let me go ahead and apply that policy. And then also a destination rule that simply identifies what constitutes version 1 versus version 2 in these services. And now if we make 100 calls off to this this endpoint, right, now we have traffic splitting going on. And so what we would expect to see is roughly 10% of those redirected to version 2 of the service. In this case, we got 6. This is, obviously this is being, it's not keeping track. You're not going to get exactly 10 each time. It's going to be based on just randomness. So there we go. So there we got 7 that time. So again, it appears to be working exactly as we specified in our policy, and that's good stuff. There is we only have 3 minutes left. There is one more exercise where we show interoperation between ambient mode and classic Istio sidecar injection mode. We're going to skip that for now. If you're interested, feel free to go through that exercise as well. And if you are interested, a couple of easy for me to say, couple of follow-up resources here. So one, if you'd like to take the exam, so that should be available for you within Solo Academy there, so you can take that, earn the Fundamentals for Ambient Mesh badge. There's also a book that that you can use. So for your next plane trip, I highly recommend this. You can get through it in an hour or two. And it's just a little book. You can get the electronic version here at this bit.ly address, and I highly recommend it. It explains everything very succinctly, but with a decent amount of detail. Okay, just a minute or two left. Are there any questions I can answer before we close up here? All right, 3, 2, 1. Very good. So thank you all for coming out today. Really appreciate your attention. I appreciate your engagement and your questions as well. If you have anything you'd like to chat about afterwards, I'll be right here. Thank you all for your time.